girl said 208. They be like, what is he? This school ugly. Sorry.
Good afternoon, class. It is time for us to do our math, so please clean your desk and let's get ready to do math. Now, we are talking about the inverse relationship today. We've discussed the inverse relationship before. I just want to see how many of you remember what inverse means. Yes. All right, that is correct. It means the opposite. Now, let's go into to this lesson today and we'll figure out what the inverse relationship is. Okay. These are our materials we're going to need today. I've already passed them out to you. You have your computers today that I sent it to you in the Google Classroom, so you can take a look at the sheets on your computer in the Google Classroom and complete them that way. Now, let's look at our standards. These are all the standards we are going to touch today, but I just want to draw your attention to this one. Students will recognize and use the inverse relationship between addition and subtraction and multiplication and division to complete basic fact sentences. Students will use this relationship to solve problems. That is the standard we're going to be covering today. The essential question: how can you use the inverse relationship between multiplication and division to solve unknown problems? I need you to be able to answer this question at the end of the lesson and tell me how we can use the inverse of a particular operation like multiplication to solve division, and how you can use division, the inverse of multiplication, to solve multiplication. Opening. Now, I have drawn a array on the board. I want you to turn and share with your peers, your partner next to you, and explain what you notice about this drawing. I'm going to be listening for some key terms that I'm hearing you use to describe this drawing. I will be walking around. All right. Great job. Tell me what you did right here. Okay. So what do you started out correctly, but it ended up something. Explain this to me. Yes. Now remember, you're adding the same equal group. So what is that called? Yes, that's right. Thank you for helping him. Repeated addition. Keep going. Yes. I like y'all discussion. Keep going. Great job. Interesting. Yes, you're okay. All right. So what would you do at this point? Right. Okay. All right. I like your thinking there. So I'm I'm seeing that, most of you have this concept, so I need to see my thumbs. Cause walking around, I can see that you're working well. I see some people who are struggling in some areas, and I'm hoping I can clear that up as the lesson go on. But give me a thumbs up if you got a grasp of what we're doing here. Sideways if you're not quite sure, and here if you need more time or more help. Great job, great job. Thank you for doing that for me. Now, I want, by you sharing your ideas, I liked Sally. Would you stand up and please explain to us what you did? Great job. I like that you used, let me write down some of these key terms that you're using. Breaking it apart is just like dividing, that's right. Great. Right. It's just like repeated addition because you're adding 12, yes. So I like the way John and Maria they had 7 plus 7 plus 7, 7 plus 7 plus 7. I like that. And so on to equals, they had 1, 2, 3, 4, 5, and on to 12, right? Right. Awesome. No, you didn't have to answer it, but and some of you did answer, and I do appreciate that. But I just want to see what were you recognizing? What patterns are you recognizing? Yes, you will. So, now, circle the multiplication division equation and write on the board, stacked on top of each other, and explain the inverse of multiplication and division to help. All right. So now that I have this, and I know that I have 7 rows, which will be my rows, so I put 7 here, rows of 12 columns, which I will put my multiplication here, and I will put my 12 here. And I know that all of this represents my answer. Right. Great job. So, who can tell me what 7 times 12 is? That's correct. 84. Now, the inverse operation, the proper definition to the inverse operation is as an operation that reverses the effect of another operation. So we like to just say, I know when I hear inverse, that means opposite. So if my multiplication is this, and I didn't know the answer, I could possibly and I knew, well, let's say I knew 84, but I didn't know how many rows I had. So I could put 84 divided by, I didn't know how many rows, but I knew how many columns, so I say 12. So all I have to do is just break it up, my rows, and then I can get it. But I know that 12 divided into 84 will give me 7. So that's also, if I know 7 times 12 is 84, I can figure out what the missing row or the missing column would be in my division. So the next one is product. Product is the answer when 2 or more numbers are multiplied together. So this would be a product because I multiplied this digit and these two digits together, and I got this digit, these 2 digits. Great job. Now, what we're gonna do is I'm gonna give you, I've already sent out a Google form, not a Google form, I've already sent out a Google Classroom document out to everyone, and it has the inverse relationship division. So, we're gonna go here, and then we're gonna work through this together. So, I'm gonna give you a few minutes to work through this, and I'm gonna walk around, and then we're gonna go over and do it. But first, let me give you, it says match the division equation on the left with the inverse multiplication equation on the right. So, the first one we're gonna do together. If it's 15 divided by 3 equals 5, then the opposite operation, or the inverse of that operation, would be what? Would it be 8 times 3 times 24? No. Would it be 7 times 2 equals 14? No. It would have to have the same numbers in it. So it would be 5, we have 5, 3, we have 3, and 15. And those two would go together. And see, we will throw that together, and that will go there. And now this the second one for you too. So if it's 12 and 6, you see it goes down here to 12 and 6. So I'm gonna walk around and see. Yes. Now, I see right here that do they have the same numbers? They do have 5, but would that be the same numbers as this one? No, so it has to be, remember what a fat family is. It has to be in the same fat family for it to be the inverse. Okay. Yes, I do understand that. Great job, keep going. Now wait a minute, let's look at this right here. Just like I just said to them, remember, it has to be in the same family. You can't have a 6 and then you have a 7. They wouldn't be the same, would they? Yes, great job. That's right. So you're looking for the same numbers that will be in the same one. Excellent job. Keep going. Explain to me what you're doing here. Oh, okay. Oh, great job. I like the way you're thinking like that. Now, most of you can continue to work. I'm going to go over the one on the bottom, so. Okay. most of you are moving. I would like to pause you right there, and I would like for you to look at this right quick. It says complete the division problem and write out the inverse equation. Now, when we're going here, we're gonna have to use the same numbers that we have here. Now, what can we use that we already know to get the missing number? Yep, fact family, that is correct. Our multiplication chart on our desk, that is correct. Yes, we could do the distributive property. Repeated addition, awesome job. We could do repeated addition. To use, those are some strategies that we can use to do this one. So let's do the first one together, and then I'll let you go back and finish what you were doing in the beginning. Okay, so right here we have 32. So instead of repeated addition, we've done something also like repeated subtraction. So we'll have 32, and then we subtract 4, and then we get, we subtract 4, and we get 28, and then we have 28, and we subtract 4, and we get 24, and then we bring the 24 over here, and we subtract 4, and we get 20, and then so forth until we get to 0. So repeated subtraction is another strategy that we could use, or we could use 4 plus 4 equals 8, and 8 plus 4 equals 12, and 12 plus 4 equals 16, and 16 plus 4 equals 20. And we can keep going on until we get to 32. But also you must always remember that when you're doing it that way, that you count the 4s up. So you count 1, 2, 3, 4, 5, and keep going until you get to the number that you stopped at. So the inverse of this would be 4 times equals 32, which we know is. So these are some strategies that we can do if you have a hard time, or you can just look at your number line and you just come up with the opposite. Great job. Continue. Okay, now, let's go over this right here, and I need you to give me your answer. Now, the answer, yep, thank you, it will be 7 times 3 equals 21, 5 times 4 equals 20. And you're right. Let's go back. And look, we've covered all of those except for a couple. So let's turn this back on. Let's do this, you're right. So we did this one already. And we did this one already. And yes, we did this. We did this one. You're right. This one. And this one. You did an excellent job, thank you. And I'll walk around and we'll check the rest of them. Now it's time for us to go to the next part. Excellent job. Now, as a class, we're going to do this, we're gonna play this. So, now that we know how to do the inverse of multiplication, now let's use the inverse of division to answer use multiplication to answer the division problem. So, 60 times 5 is, yes. Great job.
Awesome!
That startled me. Let's go to the next one. And we're just gonna do a couple of these, and I've already sent it out to you in your Google Classroom that you can play in when we get on our centers, and the group, you get to play as we do our rotations. Great, and here it comes.
Yes!
Okay, awesome. Now, it's time for us to go into our work groups. And like I said, some groups will be in the division factor. You know what group we already went over, what groups we are in, and those are the ones that are gonna be doing that. And now I've already distributed out the review, and I need you to take your time of 15 minutes rotation and do these, and then take your other one, and we're gonna review. Use our review. Okay, I'm gonna walk around. Great job.